Om Namah Shivaya. Hi friends, how are you? In this video we are going to learn about pontine respiratory centers, role of vagus nerve and higher centers that control the respiration. Okay. In pons there are two respiratory centers, pneumotaxic and apneustic. The pneumotaxic and apneustic centers in pons modulate the output from medullary respiratory centers, but they are not essential for normal respiratory output. Pneumotaxic center. Pneumotaxic center is located in nucleus parabrachialis, medialis and collicofuse nucleus that are present in the rostral pons. And the neurons in pneumotaxic center are active during both inspiration and expiration. The exact function of pneumotaxic center is not clearly known. Nevertheless, pneumotaxic center coordinates respiration by switching between inspiration and expiration. Normally, pneumotaxic center inhibits apneustic center. Suprapontine lesion in experimental animals does not change respiratory rhythm, indicating that brain centers above pons don't applicably influence basic rhythm of respiration. Next, apneustic center. Apneustic center is present in the caudal pons. Stimulation of apneustic center results in prolonged inspiratory effort interrupted by brief expiration. This is apneusis. This indicates that apneustic center strongly activates the medullary inspiratory center. However, apneustic center is tonically inhibited by pneumotaxic center and therefore inspiratory drive originating in apneustic center is checked. See once again. Pontine respiratory centers. In pons there are two respiratory centers, pneumotaxic and apneustic. The pneumotaxic and apneustic centers in pons modulate the output from medullary respiratory centers, but they are not essential for normal respiratory output. First, pneumotaxic center. Pneumotaxic center is located in nucleus parabrachialis medialis and collicofuse nucleus that are present in the rostral pons. This figure shows the respiratory centers in pons. Okay, this figure shows the respiratory centers in pons. Okay, and location of pneumotaxic and apneustic centers. Nucleus parabrachialis, the pneumotaxic center is located in rostral pons. See, this is the rostral pons. This pneumotaxic center is presented in the rostral pons. Okay. Nucleus parabrachialis and pneumotaxic center are located in the rostral pons. Okay guys, next point is neurons in the pneumotaxic center are active during both inspiration and expiration. Neurons in pneumotaxic center are active during both inspiration and expiration. The exact function of pneumotaxic center is not exactly known or clearly known. Nevertheless, pneumotaxic center coordinates respiration by switching between inspiration and expiration. Normally, pneumotaxic center inhibits apneustic center. Okay, normally pneumotaxic center inhibits apneustic center. See, This pneumothorax center inhibits, this minus symbol shows the inhibition. Okay, this pneumothorax center inhibits the apneustic center. See, inhibits the apneustic center. The pneumothorax center located in the rostral pons inhibits the apneustic center. Suprapontine lesion in experimental animals does not change respiratory rhythm, indicating that brain center above pons don't applicably influence basic rhythm of respiration. Suprapontine lesion in experimental animals does not change respiratory rhythm, indicating that brain center above pons don't applicably influence basic rhythm of respiration. Next, apneustic center. Apneustic center is presented in caudal pons. This is caudal region. Okay, this is the caudal expiratory region. This is the rostral expiratory region. Okay, guys, this apneustic center is located in the caudal pons. Okay, this is the rostral pons, this is the caudal pons. This apneustic center is located in caudal pons. Stimulation of apneustic center results in prolonged inspiratory effort interpreted by brief expiration, apneusis. Stimulation of apneustic center results in prolonged inspiratory effort interpreted by brief expiratory apneusis. This indicates that apneustic center strongly activates medullary inspiratory center. This indicates that apneustic center strongly activates medullary inspiratory center. However, apneustic center is tonically inhibited by pneumothorax center, and therefore inspiratory drive originated in apneustic center is checked. See here, this apneustic center activates this plus symbol indicates the activation. Okay, this apneustic center activates the inspiratory neurons in the medulla. Okay, but this apneustic center present in the rostral pons inhibits the pneumothorax center present in the rostral pons. This inhibits the apneustic center and thus inhibits the more inspiratory effort. Okay, and this pneumothorax center acts on both inspiratory and expiratory neurons in the medulla. Okay, guys, see here, interaction between the pontine, that is pneumothorax and apneustic, and medullary inspiratory and expiratory respiratory centers. Apneustic center stimulates the medullary inspiratory neurons. See, this is the apneustic center. This activates the medullary inspiratory center. Okay, pneumothorax center inhibits apneustic center to check its output and switches between the inspiratory and expiratory neurons in medulla. This pneumothorax center inhibits the apneustic center and thus it reduces output. Okay, and this pneumothorax center is switches between the inspiratory expiratory neurons in medulla. Okay, guys, clear? Next, role of vagus nerve. Vagus nerve carries afferent fibers from lung and airways. During inspiration, stretching of lung parenchyma increases discharge of afferent fibers in vagus nerve originating from lung. The afferent vagal impulse inhibits the medullary inspiratory neurons. Therefore, the magnitude of inspiration increases following vagotomy, and vagal stimulation results in inhibition of respiration. However, disruption of vagal afferents, abolition of vagal feedback prolongs the activity of motor neurons supplying inspiratory muscles, that is, afferent activity in phrenic nerve without affecting their magnitude. Vagus nerve and demotaxic center keep the activity of apneustic center in check. As apneustic center normally activates inspiratory drive, which is inhibited by vagus nerve, vagotomy stimulates inspiration. Okay, vagotomy stimulates inspiration. Further, vagotomy following lesion of pneumotaxic center results in apneusis. Further, vagotomy following lesion of pneumotaxic center results in apneusis. See once again. Role of vagus nerve. Vagus nerve carries afferent fibers from lung and airways. During inspiration, stretching of lung parenchyma increases discharge of afferent fibers in vagus nerve originating from lung. The afferent vagal impulse inhibits the medullary inspiratory neurons. Therefore, magnitude of inspiration increases following vagotomy, and vagal stimulation results in inhibition of respiration. However, disruption of vagal afferents, abolition of vagal feedback prolongs the activity of motor neurons supplying inspiratory muscles, that is, afferent activity in phrenic nerve without affecting their magnitude. Vagus nerve and pneumotaxic center keep the activity of apneustic center in check. Okay, both these vagus nerve and pneumotaxic center controls the inspiration. Okay, as apneustic center normally activates inspiratory drive, which is inhibited by vagus nerve. This inspiratory drive inhibited by vagus nerve, vagotomy stimulates the inspiration. Okay, cutting of vagus nerve stimulates the inspiration. Clear, guys? Further, vagotomy following lesion of pneumotaxic center results in apneusis. See this figure. This figure shows effects of transaction of brain stem at various level on pattern, rate and depth of respiration. Section below medulla as one completely abolish respiration. Section below, when we cut at this level, okay, section below medulla at S1 is completely abolish respiration. When we cut here, there is no respiration at all. Okay, which indicates that respiratory center is generated in and above medulla in the brain. Okay, in medulla and above regions, this respiration is controlled. Okay, when section made below pons, that means here. Okay, This is the pons region. Okay guys, when the section at S2. Okay, below pons, just below the apneustic center S2, just below the, this is the apneustic center, this is the pneumotaxic center. Okay guys, just below the apneustic center. Basic rhythm of respiration occurs, but respiration is irregular. Okay, respiration occurs, but see here there is no regular respiration, there is irregular respiration. Okay, respiration occurs but it is irregular, which indicates that respiration rhythm is generated in medulla, that is fine tuned by supramedullary influences. Okay, and this regulation of respiration is controlled by supramedullary influences. Okay, when section is made in the upper pons, that means at this level. Okay, above pons just below the pneumotaxic center, above pons but just below the pneumotaxic center. Amplitude of respiration increases, indicates that normal pneumotaxic center inhibits S3 and apneusis occurs, which indicates that normally vagus nerve inhibit the output of apneustic center or medullary inspiratory center. Section above pons S4 does not affect respiration, which indicates that the center for regulation and generation of respiratory rhythm are located in the pons and medulla. Okay, regulation and generation are generation and regulation of respiratory rhythm are located in pons and medulla. When bilateral vagotomy is combined with S4, amplitude of respiration increases, which indicates that vagus nerve inhibits output of pneumotaxic center on respiratory centers. Clear guys? See it once again. Next, control by higher centers. Control of respiration by higher centers in the brain is more complex than the control of rhythmic pattern of respiration. Though many centers influence the activity of medullary respiratory centers, the influence from reticular activating system and limbic system is more prominent. Reticular activating system exerts a tonic drive on central pattern generator, which is increased during arousal from sleep. The drive from limbic system increases during emotional reactions. Once again, control by higher centers. Control of respiration by higher centers in the brain is more complex than the control of rhythmic pattern of respiration. Though many centers influencing the activity of medullary respiratory centers, the influence from reticular activating system and limbic system is more prominent. Reticular activating system exerts a tonic drive on central pattern generator, which is increased during arousal from sleep. The drive from limbic system increases during emotional reactions. Okay, I think it is clear. If you like this video, like, share and subscribe. Thank you.